Hello everyone and welcome to my SQLpassion Weekly Update. First of all, I want to say a big thank you to Microsoft because they made me a big favor. They have released yesterday the CU4 update for SQL Server 2022 so that I have today some content about SQL Server to speak to you. I have already installed that CU update. I will show you that a little bit later. And as you can see, the CU update 4 has a lot of different fixes. So much more fixes as the previous CU update. And as you can see, there are a lot of fixes in the area of query execution. So they have fixed here some issues with the UDF inlining functionality. They are also fixing some access violation errors, which are quite nasty. In addition, when you're working with the automatic plan correction feature of SQL Server 2022, Microsoft releases with that CU update 2 new trace flags with which you can do some experiments with. You can also see that we have here a lot of different fixes in the area of the query optimizer. So for example, we have here a fix regarding a memory leak, quite interesting. And yeah, a few other things regarding replication. I don't have any idea about replication. I think this is one of the features that I'm not touching in any way in SQL Server. And in addition, there's also one fix regarding SQL Server on Linux. Let's go here to Azure Data Studio. I have here a virtual machine running. And as you can see, when we do here select add version, you can already see that I have applied that CU update just a few hours ago. And as I've said, Microsoft released that CU update yesterday. So if you are on SQL Server 2022, please make sure to check out that CU update, because as you have seen, Microsoft introduces here a lot of different bug fixes across the various feature areas of SQL Server. Today I also want to talk about a very famous weblog, the weblog from Frank Denneman. Frank Denneman is a Dutch guy and he works as a chief technologist at VMware, and Frank is very well known for his NUMA deep dive series that he has written years ago on his weblog. And in that deep dive series, Frank describes NUMA systems, how they are working on VMware. And trust me, if you're running SQL Server on NUMA systems, you will also gain a lot of additional new knowledge how SQL Server would work on NUMA systems. And these days, Frank specializes in machine learning workloads which are running directly on VMware ForceSphere. And a few days ago, Frank has published a new weblog in his Accelerator Deep Dive series about fractional and full GPUs. So normally when you are specialized in machine learning, you already know that you are using here GPUs, so graphic cards, because with GPUs you are just able to massively parallelize all the training process of your neural networks and everything. And in this weblog, he covers a lot about the machine learning development life cycle. And when we go down, he talks here about full GPUs and also about fractional GPUs. As you can see, he talks here about NVIDIA GPUs, and that one here, the A100 GPU, is a quite interesting one, because with that GPU you can split it and assign parts of that GPU to individual virtual machines that you are running on top of VMware vSphere. But this is a very expensive GPU. I have just googled for it, and I think that GPU costs you more than $10,000, so nothing that I want to buy for my own home lab. But yeah, if you're interested in the GPU development, how you can run machine learning workloads on top of VMware vSphere, please make sure to check out Frank Denneman weblog because it's very interesting these days. The last thing I want to talk about today to you is about my OS development stuff. As you might know, I'm a quite crazy person. I'm doing crazy things. For example, years ago I have implemented my own CPU out of discrete TTL chips, and these days I'm working on implementing my own x64 based operating system. I have started with my operating system, I think, almost 10 years ago, and currently I'm just rewriting for the third time in my life my operating system, because yeah, writing an operating system is a quite complicated task, and the last two times, more or less, I have failed, and now with the third iteration, I'm trying just to getting better and better, and I'm praying that I don't have to do a rewrite the fourth time. And this week I have achieved a quite amazing milestone, because I'm now already able to run programs that I'm loading off from a file system. First of all, I just want to show you how the operating system look like. It's not very fancy, nothing. It's currently just a console based operating system. So as you can see, I'm running it here in VMware Workstation. It also works on physical hardware. And currently I'm just doing a simple printf call from two programs that I have loaded off from a FAT12 partition. So nothing special here. First of all, as you can see from that output, I'm doing here already multitasking across one CPU core. I've not experimented currently with working more than one CPU core. I'm just working here on the core 0, and on core 0 I'm doing a software based multitasking. Means I'm just switching here between the individual tasks which are getting started up during the boot process of my operating system. Very important to know here is that I have a fully working kernel which is running in ring 0 of an Intel CPU, and the user programs that you are seeing here, program 1 and 2, they are already running in ring 3 in the user mode ring of the Intel CPU. So I have a whole separation between user mode programs and the kernel mode, which just provides services to the user mode applications, and the user mode applications are just communicating with the kernel through system calls. And also very important point to mention here is the fact that each user mode program already runs in its own virtual address space. Means both user mode programs are loaded to the same virtual base address, and each user mode program just sees its own virtual address space. So this is already a quite amazing milestone that I have achieved during that week. I just want to show you here some code. As you can see, almost everything is here C-based, assembler-based, so we have here no .NET framework or anything available, just raw per metal OS programming. That function create initial tasks is called when my kernel is starting up, and as you can see, I'm loading here two user mode programs from the FAT12 file system. I'm just using here FAT12 because it's just easier to implement in comparison to FAT32 or anything else. So we have here those two user programs. I can show you the code here. So we have here program 1, program 2, program.c is the entry file. As you can see, program main is the entry file, and within a simple endless while loop, I love endless loops, I'm just doing a simple printf call. As I've said previously, that program is running in user mode. As you might know, in a user mode process, you don't have access to kernel memory. So when you want to write out to the screen buffer is just mapped into kernel memory, and that kernel memory is not accessible to a user mode application. Means that printf call is now doing a system call into the kernel, which is running in ring 0, and in ring 0 your code can do anything. You can access all the memory, physical virtual memory, you can access hardware devices through input-output boards, so you can do everything. So my user mode application calls printf, and printf is doing a simple system call into the kernel. That's a system call with just one parameter, the string to print out. The first parameter is always the system call number. As you can see, currently I have just one system call defined, the system call for printf, and that system call is just done in assembly. So as you can see, we have here syscall.asm, and here I'm just raising the interrupt 0x80, so the same thing as Linux is doing. When that interrupt is raised, that interrupt is catched by the kernel. I'm catching it here in syscall.asm. I have here a syscall handler which is fully written in assembler. So I'm just saving here the general registers on the stack. And then I'm just calling my syscall handler, which is implemented in C. We have that one here, and as you can see, I'm getting the syscall number from the which is the RDI, which always contains just the first best parameter. Then I'm checking if we have a printf system call, and if yes, I'm just doing a printf call within the kernel, and the string to be printed out is passed in the which is the RSI. So that's just a traditional x64 calling convention. So quite interesting things that I'm doing here. As you can see here, you have here my GitHub repository within SQLpassion. You can see here all the code of which my OS contains. More or less I'm working here with two branches. I have my main branch, which is the default one, and all the new stuff is always developed in the feature branch. So currently I'm here in that branch process creation. It's more or less the 11th feature that I'm trying to implement in my OS. So this is more or less the ongoing work, which doesn't damage in anything my main branch. As you can see, I've already done here 9 commits, and over the next days I will merge that feature branch into the main branch. So if you're interested in some low-level stuff, if you want to see how an x64 based operating system can be implemented, please make sure to check out my GitHub repository. You can also find here some blog postings that I have already written in the past about OS development. Haven't done here that much in the past because of time restrictions, but over the next time I hope that I have some additional time to continue here my working. So thank you for attending or watching, listening my SQLpassion Weekly Update today. I can't promise that I'm making a weekly update next week because I'm traveling with Philip again on Wednesday to a chess tournament which is running from Thursday to Sunday. So I don't think that I will do a weekly update next week because I don't have that much to talk about. But as I have mentioned in my last weekly update, you can follow and watch Philip's YouTube short videos to see how he performs during his next chess tournament. So thanks for watching. Stay tuned and see you very soon again. Thank you.